Hi there and welcome to Mr. Arnold's Maths. In this video we're going to look at the Further Mathematics Level 2 certificate that's been provided by AQA this year, and we're looking at practice paper set 1, paper 2, which is the calculator paper. So let's crack on with question 1. Okay, so we're told that the ratio of males to females at a party is 3 to 5, and there are 12 more females than males, and we're asked to work out how many people are at the party. Well, if I just draw you a little diagram to kind of represent what's going on here, we've got males to females, and it's in a ratio 3 to 5. That means for every 3 males we should have 5 females. 3, 4, 5. Now it tells me there are 12 more females, which means that this 2 parts here must represent 12 people. We're asked how many people are at the party. That means, well, if 2 parts is 12, 8 parts is going to be 4 lots of 12. 4 times 12 is 48. Okay, question 1b. We're asked to show that A% of B is the same as B% of A. Before I show you algebraically, let's just think of an example. If I think of 50% of, I don't know, say 20, well, we know that's 10. Well, what's 20% of 50? Well, 50 divided by 5 is also 10. So it seems to work. How can we show it algebraically? Well, of in mathematics generally means multiply, so we can use that fact. And A%, which is going to be A over 100 of B, so times that by B, equals AB over 100. And B% of A is going to be B over 100 times by A, which is BA over 100, and AB over 100 is the same as BA over 100, so this is correct. Question 1c. So we're told that a runner increases the distance she runs by 10% each week, and in week 1 she runs 16 miles, and every week she's going 10% more. We want to know which week it is she first runs more than 20 miles. So what I did was I said, well, week 1 equals 16 miles. Week 2 is going to be equal to 16 miles plus the 10%, so multiply that by 1.1, which gives us 17.6. Week 2, or week 3 should I say, is going to be 10% more than week 2, so 17.6 multiplied by 1.1, which gives us 19.36, and week 4 is 19.36 multiplied by 1.1, which gives us 21.296. So it will be week 4. 2a. So expand and simplify. So take the number on the outside, multiply by everything inside the brackets. 4 times 2x is 8x. 4 times 3 is 12. 2 times x is 2x. 2 times minus 7 is minus 14. 8x and 2x is 10x. And 12 take away 14 is negative 2. Okay, expand. M cubed times by m plus 2. M cubed times m is m to the power 4, and m cubed times 2 is plus 2m cubed. So some handy marks there if you're decent with your algebra. 2c, solve this equation. So I'm going to start by timesing both sides by 4. So multiply everything on the left and everything on the right by 4. If I times this side by 4, we end up with 9 minus 2d. Times the right hand side by 4, so we'll have 4 times by 1 minus d. Let's expand out the brackets. 9 minus 2d equals 4 minus 4d, and let's now add 4d to both sides. So I'm going to add 4d to both sides. we get 9 plus 2d equals 4. I'm going to take 9 away from both sides. We get 2d equals negative 5. And dividing both sides by 2, we get d equals negative 2.5 or minus 2.5. So negative 2.5. If you want to check your answer, substitute it back in here on both sides and you should find that both sides balance. Question 3. So we're told the nth term of a sequence is 4n minus 10, and we're asked, first of all, to show that n plus 1th term can be written as 4n minus 6. Well, all I got to do is replace the n with n plus 1. So we get 4 times n plus 1 minus 10, which equals 4n plus 4 minus 10, and tidying up, we get 4n minus 6, which is exactly what we were asked for. Next part, we're asked to prove that the sum of any two consecutive terms is divisible by 3. Well, if suppose that's the first term, and this bit would be the next term up because it's n plus 1. If I add them, because it says sum, it should be divisible by 8. So let's see. So the first term is going to be 4n minus 10. The next one in the sequence is this 4n minus 6, because we've tidied this up already. The sum, so if I add them together, we get 8n minus 16. Is that divisible by 8? Well, absolutely, because I can factor out the 8. Factorizing out the 8, we get 8 into n minus 2, which is divisible by 8. Okay, moving swiftly on. Next one. We're given a different sequence here, and we're asked to explain why 1 is not a term in the sequence. Well, if 1 was a term in the sequence, we should get this. We should be able to let the sequence equal 1. So I should be able to say 3n over n plus 5 should be equal to 1 if 1 is in the sequence. So multiplying both sides by n plus 5, we get 3n equals n plus 5. I'm going to take n off both sides, so we get 2n equals 5. That would mean n is equal to 2.5. N, let's just use a small n. N must be an integer value. N must be an integer. N tells us what term in the sequence it is. So you have the first term n is 1, second term n is 2, third term n is 3, 50th term n is 50, etc., etc. Well, you cannot have something in between an integer value. So in this case, 2.5, nah, doesn't work. So that's why 1 is not a term in the sequence. Okay, we're asked to show the limiting value of the sequence as n goes to infinity. So basically what it's asking is, what does the sequence head towards as n gets bigger and bigger and bigger? So if we just think about it like this, suppose we let n equal 100. So let's work out the 100th term in the sequence. We would get 3 times 100, which gives us 300, divided by 100 plus 5, which is 105. And that is roughly around, let me see, 2 and 6/7, I think it is, 2 and 6/7. Okay, that's if n is 100. Well, what if n is equal to 1,000? We would get 3,000 over 1,005. And when we work that out, that's approximately 2 and 66 over 67. Well, this is incredibly close to 1. That's kind of close to 1. So I think I know where this is going. Well, suppose n was equal to 1,000,000. 1, 2, 3, 4, 5, 6. We would end up with 3,000,000 3 million over 1 million and 5, which is really close to 3. So as n gets bigger and bigger and bigger, the answer seems to be getting closer and closer to 3, and that is the limiting value or the limit of the sequence. These are approximation signs. They should be equals because they're absolutely correct. That should be equals and that should be equals. Anyway, on we go. This one was a tricky question. So we're given the coordinates of a triangle and we're asked to work out the area of the triangle. Now, most of you should know that the area of a triangle is generally the base times the height divided by 2, or half the base times the height. Well, in order to get the base, I'm going to have to work out this. I want to work out the base of this. So I need the distance from here to here. So I'm going to use the distance formula. And the distance formula, in case you don't know, make sure that you do before your exam comes around, is going to be the difference of the x's squared plus the difference of the y's squared. So it's actually derived from Pythagoras' theorem, but we don't need to go into that now. So the distance from C to B, so let's work out the distance CB is going to be equal to, I'm going to let this be x2 and this be x1. This will be y2, this will be y1. Now it doesn't matter which way you put these because we're going to square our answer. That will get rid of any problems we may have with negative signs. So let me see, x2 is 7, so you get 7, take away 5 to be squared, plus 4, take away 6 to be squared. 4, take away 6 to be squared. Plug that into your calculator if you like. 7 minus 5 is 2, 2 squared is 4. 4 take away 6 is minus 2 squared is also 4. 4 plus 4 is 8. So the distance from C to B is root 8. I'm also going to need the perpendicular height, so I need to find out the midpoint here. If I can get the midpoint of this and then work out the distance from here to here, I will then have the perpendicular height. So we'll have the base and the perpendicular height, and we can use the formula. So let's get the midpoint. The midpoint, call it MP, is going to be, well, it's going to be halfway between 5 and 7, and halfway between 5 and 7 is 6, and halfway between 6 and 4 is 5. So the midpoint is 6, 5. So we have the midpoint. Now I'm going to work out, let's call the midpoint, let's call that D. I'm now going to work out the distance from A to D. So let's work out the length of AD. AD is going to be equal to, let me change colored pens here. D is 6 and 5, and this is 2, 1. So let's call this x1, y1, and this can be x2, y2. Right, so we're going to take the square root of x2 minus x1, so 2 minus 6 to be squared, plus the difference in the y's, 1 take away 5 to be squared. 1 take away 5 to be squared. As I said, it doesn't matter what you label these. If that's x1, that must be y1. If that's x1, that must be y1, but it doesn't matter what you label. When we square it, it will get rid of any issues. Okay, so 2 take away 6 is negative 4. Negative 4 squared is 16. 1 take away 5 is negative 4. Negative 4 squared is 16. So 16 plus 16 is 32. Right, so it's going to be a half. The area is going to be a half. The area A is going to be a half multiplied by the base, which is root 8 units, multiplied by the perpendicular height, which is root 32 units. When we work all of that out, plug it into your calculator, it is a calculator exam, we get 8. Okay, so moving swiftly on, we're asked to solve this quadratic. Well, I'm going to take two numbers that multiply to give me 28 and add to give me negative 11. Two numbers that multiply to give me 28 is going to be minus 7 and minus 4. Minus 7 times minus 4 is 28, and minus 7 plus minus 4 gives me minus 11. That means x must be equal to 7, or x is equal to 4. The product of two terms is 0. That means this term or this term must be equal to 0, or both are equal to 0. And solving that, we get 7 and 4. Okay, so now we're asked to use our answer to part A to solve this problem here. And it actually looks incredibly similar, except instead of having x squared, I now have x, and instead of x, I have the square root of x. So that means these answers are going to be related. Well, if I was to solve this using a kind of a similar method, I would get the answers to root x and root x. And we should get the same numbers because all the numbers are the same. So root x would be equal to 7 and root x would be equal to 4. Well, that means x must be equal to 49 and x must be equal to 16. And there's your 2 marks. Moving on, we're given a triangle here and we're asked to work out the smallest angle in the triangle. So I've got an angle here and I've got the opposite side. I've got a side here, and I'm guessing I'm going to want to work out this, call it theta if you like. So using some trigonometry and the sine rule, we know that the sine of theta divided by 9 should be equal to the sine of 71 divided by 10. That means sine of theta should be equal to 9 times by sine 71 over 10. And I'm going to get my calculator here and plug these values in. So I'm going to do 9 multiplied by, open some brackets, sine of 71 divided by 10. And I get 0.851 if I round that appropriately. 0.851. Take the inverse sine to get the angle. So that means theta is roughly around 58.32. 58.32. So theta is 58.32. And I need to work out this one as well, just to be sure. Let's call it tau. So that means tau, which is another Greek letter, is going to be equal to 180, take away 71, take away 58.32. So putting that into a calculator, 180, take away 71, take away 58.32, and we get 50.68. 50.68. Well, the smallest angle is certainly this one. So that's our answer, 50.68. Okay, question 7. So we're given a diagram with a vertical mass 12 meters high and some points around it and various different other pieces of information. We're asked to calculate the distance CD, so I need this length here. Well, if I just look at this triangle here, the triangle CBD, we can see that it's a right angle triangle. So I'm starting to think Pythagoras could be useful here. How would Pythagoras be useful? Well, if I knew what this length was here, and if I knew what this length was here, I could use Pythagoras to get this, which would be the hypotenuse. So using this side here and this angle, can I work out this here? Well, we can. In relation to this angle, this is the adjacent side, and this is the opposite side, and that involves the tan. So I know that tan of 35 is equal to the opposite over the adjacent, which I'm going to call a, small a. So that means a must be equal to 12 over tan of 35. And 12 divided by tan of 35 gives us 17.14, which is roughly 17.14. So let's just replace that a now at 17.14. Okay, this is coming along nicely. This one I'm going to call b. So again, in relation to this angle here, that's the opposite, and that is the adjacent. So again, we're going to use tan. Tan of 23 is going to be equal to 12, the opposite, over b, the adjacent. That means that b is equal to 12 over tan 23. And let's just put that into our calculator here. 12 divided by tan of 23 gives us 28.27, which equals 28.27. So nearly there, 28.27. Okay, and that means CD must be, so CD squared must be equal to, using Pythagoras, 17.14 squared plus 28.27 squared, which equals, so let's do this, 17.14 squared plus 28.27 squared gives us 1092.9725, and that means CD is going to be the square root of all of this here. So use your calculator. Second function, take the square root. Square root of 1092.9725, which is 33.06. So let's take that, 33.06, and there is your 6 marks. A lot of work going for that, but not the worst question in the world. Right, let's just fill that information in here. 33.06. Always good practice to fill in any information you get as you go. Okay, we're asked to work out now the bearing of D from C. Okay, so what I need is, I need the bearing. If you imagine that's a north line, I need this bearing here. Well, first thing, you have got to absolutely ignore this angle here. It's nothing to do with that angle there, because that is going off into a different direction. We're not concerned with that. What I do need is this angle in here, this little angle here between this line. Let me just change color pen so you can see. So I want this angle here. Now, let's make it a little bit bigger. So I want this angle here. If I get this angle here and add 90 to it, that will give me the bearing. Remember, bearings are always given in 3 figures, measured from the north line in a clockwise direction. So let's call this angle theta. So I want to work out theta. Right, what do I know that I can use to get this angle? Well, we can use this, you could use this or this. Any of these numbers will work. I'm going to use this one and this one. So in relation to this angle, that's the opposite, and this is the adjacent. So again, we're looking at tan. Tan of theta is going to be equal to the opposite, 28.27, over the adjacent, which is 17.14. And let's just do that on a calculator. 28.27 divided by 17.14, which gives us 1.6, let's say 1.649, and then take the inverse tan to get the answer. That means the angle is going to be 58.77. So theta is 58.77. I'm going to have to add on 90 degrees to get it correct. So adding on 90 degrees, we get 148.77. We want it to the nearest degree, so let me just modify my answer here. Always reread your question. So to the nearest degree, 148.77 is in fact 149. So do be aware of that. I wanted my answer to the nearest degree, 149 degrees. Okay, this question was a little bit tricky the first time I looked at it, but it was deceptively easy actually. So we're given a function f of x, and it's defined as this: 22 take away 7x, and this is the domain of the function. That means where we're this is where we're interested in the function, between -2 and up as far as p, wherever that may be. It tells us the range of the function goes from -13 up to 36, and we're asked to work out p. Now the way I did this was I tried to visualize what this looks like. So if we think about it by just sketching a little graph here. So this is actually a straight line with a gradient of -7, and it cuts the y-axis, or in this case the f of x axis, at 22. So it's going to cut somewhere here, that's 22, and it has a gradient of -7. That means it's quite, steeps down like that fairly quickly, goes off in that direction, and it would be up here somewhere. And it tells us that the range is -13 to 36. That means somewhere up here, so that would be around 36. So that's as high as it gets. -13 would be somewhere down here. -13. And any other information we could put in there? Oh, -2 up to p. So I know that this bit here is -2. It would have to be because it's to the left. And I want to know at what value does it hit its lowest value. So if you look, when I put -2 in to this, let's just check that out. 22 take away 7 times -2 gives us 36. So this -2 part gives us this. That means the p should give us -13. So if I replace the x with p, it should be equal to -13. So if I say 22 take away 7 times p should be equal to -13, minus 7 p, taking 22 from both sides, should give us -35. That means p should be equal to 5. And that is absolutely correct. If you don't believe me, let's just have a quick look. So let's put in view, keyboard. Right, so I just want to draw the line. Call it y if you like. You can call it f of x, but I'll just call it y. Y equals 22 take away 7x. And if you have a look, let's just move that away. So going right the way up. So we said when when we have negative, when x is negative 2, we should get 36. So 0, negative 2. Oh, look at that. There it is right there. That's negative 2. That's 36. And also, when x is 5, when x is 5, we should get negative 13. X is 5, we get negative 13. So we're absolutely spot on there. Okay, we're asked now to express this function in the form x minus a all squared plus b. So what we're doing is we're completing the square. So nice and easy, half whatever's in there. So we get x minus 2, square it, and then we have to add something on at the end. Let's just work out what x minus 2 squared is. X minus 2 squared is actually x squared minus 4x plus 4. I don't want plus 4, I need plus 5. So I'm going to have to add 1 on, and that's my b. We're asked to write down now the range of g of x. So what would the range of g of x be? And again, it's good to try and picture or visualize what this function looks like. It's actually a parabola or a U-shaped graph, because it looks like a quadratic, so that means it's going to swoop down and go off up here in this direction. And where is this function defined? Well, it's defined everywhere. G of x is defined everywhere greater than or equal to 1. It actually comes from this bit here. So again, if you're not sure, pick a couple of points, plug it in here, sketch your graph, and you'll see that the function is actually defined everywhere above 1. Let's just take a look. So x squared minus 4x plus 5. Let's bring up a new page. Right, x squared minus 4x plus 5. Oh, we should put y equals 5. So yeah, my graph wasn't brilliant, but sure, we get the idea. As you can see, the function is defined everywhere above 1. Absolutely everywhere above 1. Okay. Let's move on. Right, we're told that the equation of line A is y equals 5 minus 2x, and it tells us that B is parallel to A and it passes through this point. We're asked for the coordinates where it intersects the y-axis. There's a couple of things going on here. Right, if B is parallel to A, that means it has the same gradient. Parallel lines have the same gradient. If it passes through this, and I know the gradient, I can use the formula y minus y1 equals m times x minus x1. So we can use this to work out the equation of the line. But also, I know that I'm interested where it intersects the x-axis, and where it intersects the x-axis, y must be 0. So I'll come back to that bit in a second. Let's just fill this in here. So we would have y minus y1, which is 7, equals m, the gradient, times x minus x1. Minus minus 3 is plus 3. So y minus 7 equals minus 2 times x plus 3. So let's just tidy that up. Y minus 7 equals minus 2x minus 6. So y equals minus 2x, adding 7 to both sides, plus 1. Okay, so that's the equation of the line. Where does it cross the x-axis? Well, when it crosses the x-axis, doesn't matter what line you have, everywhere on the x-axis, y must be 0. Y is equal to 0, so this must be 0. So we get 0 equals minus 2x plus 1. That means minus 2x equals minus 1. So x equals a half. So when x is a half, y is 0. And that's it. That's the coordinates of the point where it crosses the x-axis. Right, let's keep going. Factorize fully. N cubed minus n. So factor n out and we get n squared minus 1. Now that will only give you one mark. Be very careful. Look at this here. We got n squared minus 1, which is actually the difference of two squares. That can be factorized even further to n minus 1 and n plus 1. And the next bit we're asked to explain why it's divisible by 6. Right. Well, if you think about it here, suppose we had a sequence of numbers, consecutive numbers. That could be the first, that would have to be the second because I'm adding one on, that would have to be the third because I'm adding one on. And that means that one of the factors, so one of these factors must be a multiple of 2. One of the factors must be a multiple of 3, and 2 times 3 equals 6. So we've got a multiple of 2 in there somewhere. It doesn't matter which one it is. One of them has to be a multiple of 2. One of them also must be a multiple of 3. And a multiple of 2 times by a multiple of 3 must be a multiple of 6. Okay, some tricky indices questions here. So we're given x equals 5 to the power m and y equals 5 to the power n. We're asked to write 5 to the power m plus 2 in terms of x and give our answer in its simplest form. So we've got to think about this. 5 to the power m must be x, so we'd have x. Now, how would I get that extra plus 2? How do we do that? We get that by multiplying by something that has the same base. When we multiply these things that have the same base, x times by 5 to the power 2 is the same as 5 to the power m times by 5 to the power 2, which would give us 5 to the m plus 2. So x times by 5 to the power 2 is the same as x times 25, or 25x. Write this in terms of x and y. So 5 to the power m is x minus n. Well, when we take powers away, generally that's by dividing. So x divided by y, or if you like, x over y. 5 to the power 3n in terms of y. So let's have a look at this. We would have, so y equals 5 to the power n, and we want 5 to the power 3n. So the n has been multiplied by 3, which I can also write like this. 5 to the power n, all to the power 3 is 5 to the power 3n. That must mean that the answer must be just 5 cubed. 5 cubed will give me this. Sorry, y cubed should I say, should give us that. So the answer is y cubed. And finally, 5 to the power m plus n over 2. Well, just looking at this carefully, m plus n over 2 is the same as m over 2 plus n over 2. So what I want is this m to the power of a half, and sorry, m over 2 plus n over 2, we're going to write as x to the power of a half times by y to the power of a half. 5 to the m over 2 is simply x to the power of a half, and 5 to the n over 2 is y to the power of a half. And that's how we manage that one. Okay, so we got a square and two circles here, and we're asked to show that big R equals small r times root 2. So this one is kind of tricky, but if you use some general reasoning, and if we look at this here, that's the radius of the little circle, and this will be the radius of the big circle. And if I just take my highlighter pen, I hope you can see that this shape here is in fact a right angled triangle. So this is a right angled triangle. So what comes to mind straight away is Pythagoras. Now if that's a radius there, this also is a radius the same length. If you're not too sure, now this won't be drawn accurately, so it may not work, but there's your radius, and if I carefully just move that up here, there you go, it fits in nicely for us. So this radius and this radius are the same. Right, so we're asked to show that this equals this. Well, using Pythagoras, radius squared should equal small radius plus small radius. That means the radius squared should equal 2 times the small radius. And that means the radius, the big R, if I take the square root of both sides, will equal, well, the square root of small r squared is r, and the square root of 2 is root 2. And there's your 3 marks. Okay, asked to solve an inequality problem. So, just like solving an equation, I'm going to take 2y off both sides. So, taking away 2y, we get 3y. Take away 4 less than 6. And now I'm going to add 4 to both sides. We get 3y equals 10. And then finally, I'm going to divide both sides by 3. So that means, oh, I said equals. That shouldn't be equals. It should be less than. 3y is less than 10. That means y is less than 10 over 3. So y is less than 10 over 3. And there's your 2 marks. Right, solving this. Well, using the knowledge that we already have, this looks like a quadratic, so I'm going to treat it like a quadratic. So I need factors of negative 3 that add to give me negative 2. And with a little bit of thought, we get negative 3 and plus 1. So that would give us, if it was an equality, if it was equal to 0, we would get x is equal to 3 and x is equal to negative 1. Now this is where you need to be a little bit careful. So again, if you want to think of the graph, so just a quick sketch, I want to know where is it greater than or equal to 0. Now it's a parabola, which means it comes down like this. It's a U-shaped graph. Where is it going to be greater than or equal to 0? That was a pretty terrible graph. Where is it going to be greater than or equal to 0? It must be greater than or equal to 0 when it's less than or equal to -1 and greater than or equal to 3. So we'll say x must be less than or equal to -1. So everywhere to the left we get it's greater than 0, and everywhere to the right it's also greater than 0. So where x is greater than or equal to 3. So let me just draw you that graph using my new favorite tool, Autograph. Bring up a new page here. Okay, so we want y equals x squared minus 2x minus 3. Let's see, and there we are. Voila. You can see that everywhere that's less than or equal to -1, and everywhere that's greater than or equal to 3, we get a solution that is greater than or equal to 0, which means above the x-axis. Fantastic. Alright, moving on. Question 14. Work out the stationary points on this curve. So the stationary points are points on the curve when it's neither going up nor going down. In other words, it means the gradient is equal to 0. So I'm going to use gradient function. I'm going to find out the gradient function by taking the derivative. So dy dx is equal to 3x squared minus 12. You do the power by the coefficient of x. So 3 times 1 gives us 3, and then reduce your power by 1. So 3 becomes 2. So I want to know, where is this function going to be equal to 0? So I'm going to do dy dx, dx, and I'm going to evaluate it. No, I'm going to let dy dx, should I say? Let dy dx equal 0. So we get 3x squared minus 12, that should be equal to 0. That means we can divide everything by 3. We get x squared minus 4 must be equal to 0. That means x squared should be equal to 4, which means x is equal to, and always important here that we do plus or minus 2. Because we take the square root, the answer could be plus or minus 2. So let's see what happens when x equals 2. What do we get? When x equals 2, what do we get for y? So we get y equals, so we're doing x equals -2. I'm going to substitute it back in here. When x is -2, we get -8. -2 times -12 is 24 plus 24, which gives us 16. So that means one of the stationary points is -2 and 16. And the other stationary point is going to come from when x is plus 2. So when x is equal to 2, y must be 8 minus 24, which gives us minus 16. So when x is 2, we get minus 16. So they're your two stationary points. Again, let's just check that. I'll just show you on autograph. Y equals x cubed plus minus 12x, right? So y equals x cubed minus 12x. Let's draw this. Y equals x cubed minus 12x. And we should see that the curve turns at stationary points. Where does it go? Neither go up nor down. Right here. When x is -2, y is 16, the curve is neither going up nor down, and also down here when x is 2 and y is -16, again the curve is going neither up nor down. and therefore is a stationary point. Now, we're asked to sketch this curve. So we had when x is negative 2 and y was 16, so say that's negative 2 and y was 16, we had a stationary point there. When x was 2 and y was negative 16, we had a stationary point here. Anything else we know? Well, what about when x is 0? When x is 0, y is also 0, so substituting it in, we get one there. So I know my curve is going to come down like this, and it's a cubic, which means it's going to take this shape here. And there are your 3 marks. So 1, 2, 3 marks for those 3 points of interest. On we go. Okay, we're given a quadratic graph, and we're told it intersects the x-axis here and here, and we're asked to work out the equation of the quadratic graph and give your answer in this form. Well, if it cuts here and here, if these are solutions, that means I can say x minus a half multiplied by x minus 5 should give me a solution. So x times x is x squared, x times minus 5 is minus 5x, minus a half times x minus a half x, and minus a half times 5 is plus 2.5. Tidying that up, we get x squared minus 5.5 x plus 2.5. And again, we want it in this form here. It says a, b, and c must be integers. That means they must be positive, or they must be whole numbers, not positive numbers. Positive or negative whole numbers. So I'm going to multiply everything in this by 2. So we get 2x squared minus 11x plus 5. So the answer is y equals 2x squared minus 11x plus 5. And I'm not going to show you using autograph what that looks like. Take it from me, it works perfect. Okay, we're asked to solve this equation between 0 and 180. So what we do is we need to take the inverse sine of 0.8. 0.8. So let's do that. So using your calculator, inverse sine of 0.8 gives us 53 degrees. Let's go with that. 53 degrees. Now it's a 2-mark question. It says between 0 and 180. That leads me to believe that there's also another solution. Now this is why it's important you know how to sketch the graphs of sine and cos. So I'm just going to use autograph here again just to show you. We want y equals sine x. So let's take a look at what y equals sine x looks like. Okay, so that's what our graph looks like. You should be able to sketch that. Now we know that we got a solution at around 53 degrees, I think it was, which is round about here. So we had a solution at 53 degrees, which was our 0.8. But if you have a look at the graph, you can see there's symmetry, and that means that if I take 50, so this was 53 degrees in this direction, 53, that means the other solution, which is going to come from right here, is going to be 53 degrees back from 180 because the graph is symmetric. So if you do 180, take away 53, that will give you your second solution. So 180 take away 53 is 127. 127, and there's your two solutions, 53 and 127. Okay, this one's a little bit trickier. We're asked to solve this equation between 0 and 360. Right, we have sine x and cos x. I don't like having sine and cos in the same equation, so what I'm going to do is I'm going to divide both sides by cosine of x. So if I divide the left hand side by cosine of x, we get 2 sine x over cos x equals negative 3. So dividing both sides by cos x. However, sine x over cos x is tan x, so we get 2 tan x equals negative 3, and then dividing both sides by 2, we get tan x equals negative 3 over 2. So let's just come up here. So take the inverse sine, or inverse tan. So inverse tan of negative 3 over 2. Let's just do that on the calculator. Inverse tan of negative 3 over 2 gives us, I'm getting negative 56. Right. Negative 56. Now again, you're going to want to be able to sketch these. Negative 56 is no good because I need an answer between 0 and 360. So let's just show you what y equals tan x looks like. So we get y equals t a n tan x. Right, and let's just make this look better. Okay, y equals tan x. Right, so we got an answer of negative 56. Negative 56 is going to be round about here. So negative 56. Now, if we look at the graph, where else do I get a solution that is the same as this? So drawing a line straight across, you can see that if I actually take 56 away from 180, we should get the same solution. And if I take 56 away from 360, I should get the same solution. So I'm going to do 180, take away 56, and 360, take away 56. So 180, take away 56, and I'm going to do 360, take away 56. 180 take away 56 is 124. So 124, and 360 take away 56 is 304. So 124, 124, and 304 gives you your solution. Now, some of you may have used a method called cast. I didn't show my students this method, C-A-S-T. So if you did use that, you should get the exact same answers. I myself prefer to use the symmetry of the graphs. On we go. Right, so now we're asked to work out the equation of the normal to the curve at this point and give your answer in this form. Right, before I get the normal, I'm going to work out the equation of the tangent to the curve. So let's start with that. In order to get the equation of the tangent, I need to get the gradient function. So take the derivative, dy dx. Dy dx is going to be equal to 6x squared minus 2x. So that's the gradient function. And I want to know what exactly is the gradient of the tangent to the curve when x is 1. So right at this point, what is the gradient of the tangent to the curve? So dy dx evaluated when x is equal to 1 will tell me exactly what the gradient is at that point. We get 6 minus 2, which equals 4. So that's the gradient of the tangent. Gradient of tangent. Now, the normal is always perpendicular to the tangent. So if the gradient of the tangent is 4, that means the gradient of the normal is going to be that flipped upside down and change the sign. That's a quick way of doing it. So the gradient of the tangent and the gradient of the normal are always perpendicular to each other. So if the gradient was 4 here, that means the normal must be 1 over minus 4, or minus 1 over 4 in this case. So that's the gradient, and I have a point. So we have a point here, we have a point, we have the gradient, so I'm going to use the formula y minus y1 equals m times x minus x1. So substituting in y minus y1 is 2, y minus 2 equals negative 4, or sorry, negative a quarter times x minus 1. Tidying up, we get y minus 2 equals minus 1 quarter x plus 1 quarter. And taking 2 off, or adding 2 to both sides, we get y equals minus a quarter x. Adding 2 on here gives us 9 over 4. And that will do you for full marks. Y equals minus a quarter x plus 9 over 4. So that's my answer in the form y equals mx plus c. Nearly there now. Question 18. We're asked to work out the equation of the circle. Now there's lots of different ways of doing this. It's actually quite straightforward, so long as you know that the equation of a circle is given by this formula, x minus h squared plus y minus k squared must be equal to radius squared, and that's with center hk. So if I know the center is hk, I can just plug it in here and work out the radius. So I'm going to start by looking for the center. Can I work out the center? Well, we can clearly see that this is a right angle triangle, and this part is equidistant to this part. So can I use anything to work this out? Well, I can certainly see straight away that the center, well, the y coordinate must be 4. So I need to get the x coordinate. The x coordinate is going to come from this bit here. And if that's 2 and that's 6, that means this bit must be 5. So basically what I've done is 2 plus 8 is 10. 10 divided by 2 is 5. Or basically I'm looking for the point that's halfway, the midpoint between here and here. So use whatever method you like. So that's 5, 4. Can I work out the radius? Well, we can very, very easily. You can see that the radius is actually 5. From 0 to 5 is going to be the same as from here to here. So the radius is 5, the center is 5, 4. So the equation of the circle is going to be x minus 5 to be squared plus y minus 4 to be squared. And that must equal the radius squared, and the radius we said is 5. 5 squared is 25. That's for 5 marks. I said lots of different things you can do, and here you can use Pythagoras and all these other methods of doing it, but it's actually quite straightforward. Okay, I think this is the last question now. We're given a cubic and we're told 2 of the solutions, and we're asked to work out the third solution. So this is basically a factor theorem question. Well, if x minus 1 is a solution, that means if x equals 1 is a solution, that means x minus 1 is a factor. If x equals 2 is a solution, that means x minus 2 is another factor. And we're looking for this third factor, call it x minus k. Right, so let's expand this bit here to begin with. X times x is x squared. Expanding all of this, you get x squared minus 3x plus 2, and we're going to times that at some stage by x minus k. So this times this should and must give me x cubed minus x squared plus ax plus b equals 0. Let's just expand this out. If I expand this out, I should be able to equate coefficients. Let's see what happens. X squared times x gives me x cubed. X squared times minus k is minus k x squared. Minus 3x times x is minus 3x squared. Minus 3x times minus k gives me plus 3kx. 2 times x is plus 2x, and 2 times minus k is minus 2k, and that should equal the right hand side, which is x cubed minus x squared plus ax plus b. Okay, I'm going to equate coefficients, so I'm going to take everything that involves an x squared term and gather them together. So if you see this, I can actually factor the x squared out. So let's take out the x squared. So plus x squared times, what would I have to multiply x squared by? Well, it would be minus k minus 3. What about the x terms? Let's have a look here. We would take out the x, and what would we have left? We would have 3k plus 2. And then you still have the minus 2k bit. So this part must be equal to the coefficient of the x squared. So minus k minus 3 must be equal to minus 1. So that means minus k must be equal to, adding 3 to both sides, must be equal to 2. That means k must be equal to minus 2. So the other solution is x. Let me see, we'd have x minus k, x minus k, which will be x minus minus 2, which is x plus 2. X plus 2 is the other solution. That means x equals minus 2 is, x plus 2 is your factor. That means x equals minus 2 is your solution. And in fact, we managed to do this whole problem here without having to work out a and b. Now, just because I feel like it, let's actually see if we can work out a and b. So I'll just duplicate it. Let's have a look at another possible way to do this. So, well, I'm told the solutions. So I know that if I put x in here, it has to be equal to 0. And if I put 2 in here, I have to get a solution. So let's substitute 1. So I'm going to let x equal 1. We get 1. 1 cubed is 1, minus 1 plus a times 1, which is a, plus b must be equal to 0. So 1 minus 1 is 0, so we get a plus b equals 0. I'm also going to let x equal 2 and see what happens. We get 2 cubed is 8 minus 2 squared, which will be 8 minus 4 plus 2a plus b must be equal to 0. So tidying this bit up, we get 2a plus b equals minus 4. So a plus b is 0, that means, and 2a plus b is 4. Let's solve for a. So I'm going to take, let's call this equation 2 and call this equation 1. So I'm going to do equation 2, take away equation 1, gives me that, take away that, gives me a, that take away that 0, which I want. A equals minus 4, take away 0 is minus 4. So a is minus 4. And substituting back in, if a is minus 4, that means b must be equal to 4. So let's go back to our quadratic. We've got our cubic, we've got x cubed minus x squared minus 4x plus 4 is equal to 0. And again, we know that these two are solutions. So that means x minus 1 is a factor and x minus 2 is a factor. Let's multiply these two together. We get x squared minus 3x plus 2. Okay, so I need to multiply x squared minus 3x plus 2 by something else, call it x plus k, in order to get x cubed minus x squared minus 4x plus 4. Okay, so let's see if we can work this out. Well, if I do x squared times x, that gives me x cubed. X squared, let me see, what could we do? What could we do? Oh, I could do some division, couldn't I? We could do some division. We could do long division. X cubed minus x squared minus 4x plus 4. And I could do some long algebraic division. And I'm going to divide that by x squared minus 3x plus 2. When you're doing algebraic long division, you're always only concerned with the first term. So I'm going to do x cubed divided by x squared gives me x. So x times all of this gives me x cubed. X times minus 3x squared minus 3x gives me minus 3x squared. X times 2 is 2x. Draw a line. I need to make the page a wee bit bigger. Right, this has gone difficult to see here. So I'm going to have to take the bottom line away. So I'm going to take that away. That's going to have to. I'm going to have to add that. I'm going to have to take that away. So they cancel out. X minus x squared plus 3x gives me 2x squared. Minus 4x. Take away another 2x gives me minus 6x. And then we'll take down that 4. Okay, what am I going to have to multiply x squared by to get 2x squared? I'm going to have to multiply it by 2. So let's do a 2. 2 times that gives me 2x squared. 2 times minus 3x gives me minus 6x. 2 times 2 gives me 4. And lo and behold, look at this. We get the same thing top and bottom, which means when I take them away, they cancel out and leave me with no remainder. And there you go. There is your solution, x plus 2. So, or x plus 2 is your factor. That means x equals minus 2 is your solution. Right, that's it from me. Quite a tricky paper there. If you've got any questions, comments, suggestions or whatever, please do feel free to leave a comment and I will talk to you again sometime. Take it easy and best of luck studying.